Okay, so yesterday we looked at approximating areas using rectangles, and we can get an upper bound and a lower bound. Now, what we're going to do today is use something called a trapezium rule, which you did at GCSE. And the idea behind this is, if you look at this picture, if the lower bound is less than the area, the upper bound's bigger than the area. If we average the two, we should get a better approximation. Now, if we average two rectangles, look, so here's a rectangle, and here's a rectangle, just above it. If I average them, then that gives me a trapezium, look. So that's why it's called trapezium rule. So we're still going to call this distance from the bottom h, the height of the rectangles, and you could also call delta x. Now this will make more sense why we call it h, because you get given a formula, look, for a rectangle. Oh, sorry, you had to learn a formula, and we called this bit h, didn't we? And this bit b, and we said the formula was a half h, a plus b. And that's the same here. This bit's h, this height here is a, and this height here is b. Now, if we look at just three strips first of all, so this first area here would be a half h y0 plus y1. The second area would be a half h y1 plus y2. And this third one would be half h y1 plus, y2 plus y3. And then if we added them all together, look, well, look what I can do. I can factorize out the half h. So I've got y0 plus y1 plus y1 plus y2 plus y2 plus y3. So if you look, what I have is a half h, and I have one y0 and one y3, plus, and I've got two lots of y1 and two lots of y2, so two lots of y1 and y2. So you get in the formula booklet an extended version of this for when there's n rectangles, trapezium. So when there's n trapezium, the formula is a half times h, then a big bracket, or they've used a curly bracket, the first and the last added together. So y0 is the first height, and yn is the last height. The first adds last, plus 2 times all the heights, and then close the big bracket at the end. And h is still worked out the same way. It's still the difference between these numbers divided by how many trapezium. Now, the trick for this one is, on the rectangles, you always got one number that we didn't need to use. Whereas here, we'll have to use all the numbers, so that means we'll have one extra number. So if there's 4 rectangles, 4 trapeziums, 4 strips, we need 5 numbers. Look, there's 3 trapeziums here, and I need this number, this one, and this one. So 3 strips, I need 4 numbers. Sorry, I keep using the word strips because you can call them trapezium or strips. Yeah, so 3 trapeziums mean 4 numbers. And another way we can call these y values, we can call them ordinates, because it's part of a coordinate, so it's just an ordinate. So that's a new word for you there. Yeah, you don't really need to know that. So if there was 10 strips, how many numbers would you need? And hopefully you'd say 11, so you're all capable of adding 1. 20 strips, you need 21. If there was 50 numbers, how many strips would that be? And hopefully I wouldn't trick you, you'd tell me it's 49. So let's jump straight into an example. So this is the one we did yesterday. Now let's do this again using the trapezium rule with 5 equal strips. So again, work out h. So it's 1 to equal 0 divided by how many strips? So 5, so it's 0.2. Get your table of values. So x and y. So it starts at 0. We've gone up by 0.2 each time. And then use the table. I'm going to cheat. I'm going to flick back to my notes, which you can, and get your values. So it's 1, 0.9607, 0.8521, 0.6976, 0.5272, and 0.3678. So I've just got my numbers, and then the trapezium rule just says it's half times h, so half times 0.2, then I put a big bracket, first add last, so 1 add 0.3678, add 2 times the rest. Now this bit is still inside the big bracket, so it's very important when we type this in the calculator. And you get given this formula, so there's nothing to remember about this. So 0.5 times 0.2 times big bracket, 1 add 0.3678, add 2 times second bracket, 0.9607 plus 8521 plus 6976 plus 5272. Close that bracket, and remember to close the big bracket as well, so you should have 2 brackets at the end in your calculator. And that gives us 0.7443. If I just look back at the notes from last lesson, we got that, I think the exact area, actually it's still my calculator, the exact area is 0.7468. So look, it's very close to the exact value. Now, once 3 decimal places, it will read the question, 744, there we go. So this is a really good, powerful method of working out the area under a curve if you can't integrate it. So we can't integrate something like e to the minus x squared. It's impossible to integrate using algebra. So we have to use numerical methods. Okay. The only other thing they could ask you in the exams, I think we'll touch on this in the next example, I may as well mention it now. If I sketch that graph, so we want the graph e to the power minus x squared, and I want to go in, so I'm going to change my V window look. I'm going to go between 0 and 1. And I want to draw it. Can you see that the curves are always going down like that? And if you think back to your words, we could call that concave. So if you imagine drawing trapeziums underneath, so if I draw a sketch for you, so it looks like that. So if I draw my trapezium, all the trapezium would be underneath the curve. So this would be an underestimate. And if you look back at what the right answer was, it was something like 0.748. So it was an underestimate. It's underneath the actual answer. They're 1 markers. And the rule, we'll talk about the rule in a second. Okay, next one. I'll talk about the rule now. So if the curve is concave, then our estimate will be too small, so it'll be an underestimate. Look, all the trapezium are underneath. And if it's convex, then all the trapezium are over, so therefore it'll be an overestimate, it'll be too big. Okay, next one. Use the trapezium rule with 5 ordinates. So think how many strips will that be? There's 5 ordinates. To find the value of between 0 and pi over 4 of tan cubed x to 3 significant figures. Okay, so there's some potential issues here. So degrees are radians. So if we ever do a differentiation or integration, we need to be in radians always. Think, how do you type that in your calculator? Well, I'll just quickly show you that now. So let's sketch the graph. To do tan cubed x, you do tan x cubed, because that's what it means, doesn't it? Now, let me just double check I'm in radians. Yep, so I can draw the graph now. And we're going to draw to my V window. That just means my scale between 0 and pi over 4. So there we go. Zoom in a little bit. Change V window a little bit as well, just to make it go between 0 and 0.5. See what if that makes. There we go. That looks a bit better. So the curve now looks like, I think it started at the origin. curve now looks like that a bit. Okay. And why is the last value missing in the table mode? Well, it's not going to be. So ignore that last bullet point. That doesn't happen like calculators. So when we want 5 ordinates, so that means that we want 4 strips. So it's 4. So to get h, we do pi over 4, take away 0, the difference between them, divided by 4. Well, that gives us pi over 16. So we're going between 0, then pi over 16, then 2 pi over 16, which can be pi over 8, then 3 pi over 16, and then it would be 4 pi over 16, which is pi over 4. So there's my 5 ordinates and my 4 strips. Strip there, strip there, strip there, and strip there. So to get the y values, go into table, and look, tan x cubed is still there. We're going to go between 0 and pi over 4, and the step is going to be pi over 16. Draw that table, and so we get 0, we get 0.0079, that would be, then 0.071, then 0.2983, and okay, has one missing. Okay. So on our table, it's only give us 4. So to get the last one, I would go into here, into settings, and I would go between 0 and let's do 5 pi over 16, because that will be the next one, and still pi divided by 16. And the table, so our next one should be 1. So yeah, so just to quickly recap what I did there. So since it didn't give me the last one, I go to the one after it. Yeah, I will go to the one after it. Don't know why I did that for tan. And then pi over 16 still. Okay, so I've got those, and then to use the trapezium rule, we're going to do half times h times big bracket first, add last, add 2 times the middle, 0.0079, add 0.071, add 0.2983. So type that in the calculator. So 0.5 times pi over 16 times big bracket, not add 1, add 2 times 0.0079 plus 0.71 plus 2.983. Close both brackets, and we get 0.172237. 3 significant figures, so 0.172. And just to double check again, we're doing tan x cubed between 0 and it was pi over 4. So we got 0.153, so it's close to 0.172. So you can see from here, it's an overestimate. And then if we look at that picture, if we drew the trapeziums on, can you see that each trapezium, there's a bit of it that's above the curve. So that's why this number is a bit bigger than the actual area. So that's the actual area, or it's a better estimate of actual area. So this was an overestimate. And that's also because if you look at the graph, it's convex. Okay, 7. I'm just trying to think which one do I want to leave for you to do. Okay, if you want to try these two yourself, you can do. I'll keep doing them now, but if you want to try the next two yourself, because you've seen all the skills now, then you can just check your answers on here. So we've got that curve. Trapezium rule, 4 strips. Equal width is used to approximate that. So first thing we want to do is work out h. So it's a half pi, take away 0, divided by 4. That's actually pi over 8. So I'm going to draw my table. So I'm going to start at 0, then pi over 8. Then it will be 2 pi over 8, which is pi over 4. Then 3 pi over 8. Then it will be 4 pi over 8, which is pi over 2. Okay, so if I go onto table, we've got 3x times sine 2x, and we're starting at 0. We're going up to pi over 2, and the step is pi over 8. Let's see if this gives us the 5 values we need. 1, 2, 3, 4, 5. Gives us the 5 this time. So we have 0, 0.833, 2.3561, 2.4991, and 0. Okay. Show that the result can be expressed as k pi squared. Didn't read the question. So once it's written in exact terms, so that means I need to actually work these out. So this table mode always gives decimals. So what I'm going to do is I'm going to go into the run mode, look, so the normal mode, and I'm going to type in pi over 8 into that. So sine 2 times pi over 8. And then I'm going to times that by 3. That times it by 3, look, and then times it by x, which is pi over 8. So I'm going to times it by 1 over 8 and just put a pi on the end. So the first one is 3 root 2 over 16 pi. I'm going to do the same thing again, but I'm going to have it as pi over 4. And that should be 1 over 4. So 3 over 4, and stick a pi on the end. And then I'm going to go back and change it to 3 pi over 8. And then you change that to 3 over 8. I should have done all that in one go, really, shouldn't I? So it's 9 root 2 over 16 pi. So the trapezium rule is a half times h, which is pi over 8, times first at last, 2 times all the middle. So 3 root 2 over 16 pi, plus 3 over 4 pi, plus 9 root 2 over 16 pi. Now, notice when I wanted the exact answer, look, because there was pi's and square roots, that's when I didn't type pi into my calculator, apart from in trig, because I need to work out what that is. When I times by 3x, I didn't type in times 3 times pi over 8. I just put times 1 over 8 and then just stick a pi at the end. So at the front, I get pi over 16. 0, 0 is just 0. So I can put that 2 at the front now as well. And when we simplify this, well, I get what's 9 root 2 over 16, add 3 root 2 over 16 gives me 12 root 2 over 16 pi plus 3 over 4 pi. Okay, we're getting close to it. So what I can do now is I can simplify the fractions. I get pi over 8 at the front. I get 12 over 16, which gives me 3 over 4 root 2 pi. And that can't be simplified, so it's just 3 over 4 pi. Now that's nice now, look, because then I can factorize out the 3 over 4 pi. So I get pi over 8 times 3 over 4 pi. And inside bracket, I get root 2 add 1, which is what we wanted. And then I just get 3 over 32 pi squared root 2 add 1. So my k, my rational number, is 3 over 32. And then I explain briefly why it's not easy to tell from the diagram alone whether it's an underestimate or overestimate. Well, if you look at the diagram, if I split this into 4, 1, 2, 3, 4, and I draw my trapezium, then you should hopefully see that some trapezium are above the curve and some are below. So you can't tell if it's an underestimate or overestimate, because some trapezium are above the curve, like that one, and some are below the curve, like these two. In other words, the curve is convex and concave. So from here to here, look, concave, and this bit convex. Yeah, this bit was tricky because you need them in exact form, and then it's just algebra. Remember, pi's and root 2's, just treat them as like x's and y's or a's and b's and simplify them. So that's 3 over 16 ab plus 3 over 4 b plus 9 over 16 ab. Okay, it's just algebra. And then the last one, so we got a curve y equals 5 over 3x squared equal to 2. And we want the trapezium rule with 4 strips to estimate that. So straight away, before we read the rest of the question, I'm going to work out what h is. So 3 take away 2 divided by 4, because it's 4 strips, gives me 0.25. Use 2 decimal places for the y values and you're working out. So part A, I need a table, x and y. We're going to go from 2, and we're going to go up in 0.25s. Go into table mode, type in your function, 3x squared take away 2, set it between 2 and 3, it's going up in 0.25s, draw the table, so we get 0.5, 0.1, 2 decimal places in our working out, so 38, 0.30, 0.24, and 0.2. Okay, then the trapezium rule, so half times h times first, add last, add 2 times the middle. 2, 4, close both brackets, type in the calculator, 0.5 times 0.25 times 0.5 at 0.2, 2 times 0.38, that is 0.3 at 0.24, close both brackets, so we get 0.3175. And if we work out it on that calculator, 5 over 3x squared take away 2, between 2 and 3, we get 0.31497. So look how close it is. So our calculator will be using trapezium with more strips. Okay, and part B, it says here we have a line drawn at B, 2 to B, look, it looks like we've drawn a triangle, and the region S is bounded by the curve and a straight line through B and 2, 0. So to work out that S, well, S equals that whole area that we just worked out, 0.3175, take away this triangle. Well, to get the area of a triangle, I need the base along the bottom, so 2 to 3 goes along 1, and the height, well, B happens at 3, so the y value for 3 is 0.2, so that area is half times 1 times 0.2, which is 0.1. So to get the area, it's just 0.3175, so the area under the curve, take away the area of the triangle, which is 0.1, which gives us 0.2175. And that's it. That's all the kind of questions I like asking.